Go. Welcome, Peter.
Thank you,
Pleasure
Thomas.
yours.
Thank you, everybody, again. And thank you for all your kind words last time. I was quite touched by that. Thank you very much. So today, in this talk, I'm going to invite you all to get into a hot air balloon with me, and we're going to fly up into the air over the savannah, and we're going to look at the different tools that help people to deploy, to create, to optimize, and to operate something that they build with Apache Druid. Now, I'm going to presume that you know about Apache Druid and you know what it does, but if you don't, then please contact me. I can send you all sorts of links to other videos, and of course there's the meetup where I spoke last time. I think I spoke very quickly last time, but I spoke last time as well at a bit more detail. So we're going to put ourselves in the position of someone who has just started working with Apache Druid. And they've probably just started on the quick start, which is on the main website. And then we're going to follow that person as they go through their next cluster deployment and then on into a production environment. And that should take us about half an hour. And I will pause for questions at that point. And then hopefully I will be able to show you a demonstration without it crashing. So let's see if it works. So for those of you who don't know who I am, my name is Peter Marchall. I'm a technology evangelist, and I work with the open source community, open source Apache Druid community out of Imply. I've got 20 years architecture experience, as you can tell, and I've worked in all range of different technology platforms, some CRM all the way through to master data management. I've got a BA, a Bachelor of Arts degree in Theology and Computer Studies. As I always say, please don't ask me any questions about the meaning of life or about God. Well, not until I can come to Warsaw and have a beer with you, and then we can talk about God. I'm TOGAF certified, and I do collect a lot of books that I never read, and I get into trouble a lot for buying things that are far too expensive for me to watch movies on. And for those of you who know, if you're interested in Star Trek, the Prime timeline is the real and only timeline, never mind the other one, and #work. At the bottom of the slide, there are contact details for me. You've got my website on there, you've got my email address. My website has got all the LinkedIn profile information, my Twitter feed, the usual things. But it also has a block at the bottom. If you want to book a meeting with me and talk to me more, please do. That's all at the bottom of that website. Now, when I joined the team with Jelena, who's on the meetup today, when I joined Imply, rather, I was in the sales team. Don't hold that against me. I was a pre-sales engineer. I was the one who was, on the end of the phone saying, please come and buy Imply products. And I moved to join the community team in August last year. And when I did that, I got a much better insight into everything that people are actually doing with Apache Druid, whether that's someone who's looking at solar farms or someone who's looking at banking data. And so I've started to now draw this picture together of how people are deploying Druid in lots of different pipelines all across the world of all different sizes. And that's where this presentation today comes from, is just by observing what's going on in the community and trying to draw a bigger picture of what tools people are using alongside Apache Druid. And many of them you will already know, as DataOps guys, you will know some of the things I'm going to mention. You'll go, well, yes, I know where that fits. And hopefully I'll be able to kind of glue that together for you today so you can see how particular tools you already know work alongside Apache Druid. And as I go through, I will bring up links to different content that's out there on the web. So I'm sure you all like looking at my beautiful face, but if you want to bring up another web browser and look for the things I'm showing you, please go ahead and do that. And if you find other stuff as well, then let me know. Okay, so let's start our journey with our imaginary traveler as they get going with Quick Start. And this is the page on the Druid project site that everyone will be familiar with who's done this. And this is the process that it guides you through. It says, install Druid. That's a good one. Start the services, easy. go into the console for Druid, load some Wikipedia data, and then do this really complicated SQL statement. It's called a count star. And then, of course, when you've done that, you can go into production. Well, of course, you wouldn't do that. So if you've done the quick start, then take yourself back to that time when you did the quick start, and you'll remember these are the services that we were all running. We've got Zookeeper, the coordinator and overlord, the broker, the router, the historical, and the middle manager. Doesn't that look simple? Excellent. Now, through this talk, I'm going to build up one big slide. I'll show it right at the end as well, that has all of these different ecosystem functions we need to think about. So let's start this card with those components that our traveler has found when they did the quick start. And maybe this is the kind of understanding that they gained and that you've gained when you did the quick start. So we know that we have the coordinator and the historicals. What we learn is those are the processes, the Java processes that are running that are making data available for query. Then we have the overlord and the middle managers. Those two are working together to ingest that Wikipedia data. Then we have the broker. Well, we know that's the endpoint that we're sending our queries to, and the broker goes and fans out to the historical processes to go and get us the results back. And then somewhere in the mix, there's Zookeeper, lovely Zookeeper. We're not quite sure what it does in the quick start, but we know it's running. So the next thing that will happen probably is that someone will go and see a meetup. They will maybe go to a Druid themed meetup like today, or I spoke at a meetup talk in Bucharest a few months ago. Or maybe they'll come to one of the meetup groups that's dedicated to Apache Druid. Imply runs those. There's one in the San Francisco Bay Area. Maybe they'll come and meet me when I do a tech talk. Maybe I'll be coming into your organization and come and speak to your data engineers or to your architects. Or maybe they'll come along to one of the 30-minute drop-in clinics. And I put those onto LinkedIn. There's loads of my colleagues that do those. Loads of people across the world do those. And it's thanks to the organizations of the organizers of this meetup and people like Yelena, that there are places for people to go when they're on this journey to check what they understand about those very primary Java processes. So if you'd like to be involved, it's a really important part of the journey. If you'd like to be involved, then please let me know. They might come and find your organization on the Powered By page. They might read a blog post. They might come and see someone like me speaking at a meetup. Maybe they'll go and join the Druid Forum. And the Druid Forum is a place where people can talk about Druid, and they present tips and tricks and practical how-to pages. And they might meet people on LinkedIn, or they might get updates on Twitter. Now, all of this is really important at this early stage in your journey. If this is where you are and you're looking at Apache Druid, go and get involved in these things. Because of the card I'm about to show you, it can become very complicated very quickly. So come and join us and say hello. So awesome. Our traveler thinks they've got absolutely everything they need and they've been to some meetups. But the point of my talk today is that there is more to learn. So let's imagine our intrepid explorer goes back to their desk and they make a very nice sandwich, have some chips, and they decide, do you know what? Druid is really cool. I'm going to take the next step. So now they go from this single node quick start and they decide to do a multi-node deployment or a clustered deployment. And these are the steps that people go through at this point. They install Druid. Well, we know how to do that. Then they connect to this thing called a metadata database. Not really sure what that's for. And then there's this thing called a deep store. Okay, that's a bit weird. Then they have a task log store. Don't know what that is. Connect to Zookeeper. That's great. Tune the configuration. And then they grab a beer and then they go into production. Awesome. Not really. So let's start building this card up again. First of all, when you do this clustered quick start with Druid, you realize that they aren't just limited to just ingesting data from Wikipedia, which is awesome. What they learn at this point, and you'll have learned when you spin up Druid, is there are lots of different places you can ingest data from. And you need to think carefully at this point in your journey about the format of data that is supported and where it can come from. And in high volume, very high velocity pipelines, you need to experiment with different source file formats and layouts and partitioning schemes. And that allows you to make sure that the incoming data and the ingestion tasks are very happily married, living peacefully together, and that they will be fruitful and multiply. And quite early on in my journey, I came across this article. It's by Fanjin Yang. He's an original Druid developer. He's the CEO of Imply, actually. And it's called The Big Data Zoo. And it really helped me. And I'm sure it will help all the travelers who are on their Druid journey as well to go and have a look at it. And he describes Druid as a query accelerator. That's the way it's described. And he says that typically Druid sits after your data lake and after a message bus, and it provides the analytics engine that powers applications with sub-second statistical calculations that combine real-time and historical data. That's what he says. Now that means that when you're on this journey with Druid, you could ingest data into Druid from a delivery mechanism like Kafka or from Kinesis, or you might ingest it from a storage system like S3 or from HDFS. And they need to unpick what formats are readily ingested from each source, whether that's Avro or Awk or JSON or CSV or TSV, and which ones make sense in their own data pipeline. So maybe what our traveler does is to set up a producer like Devolte for clickstream analytics or OpenNTI or PMAct for network telemetry, and they push that into Kafka as their delivery mechanism. They might then do some Spark processing on that, push that back into Kafka again, and then because Druid can ingest directly from Kafka, they're going to skip the storage layer. They're not going to put that straight into S3. They're going to push that straight into Druid and then present that for exploration in superset in real time. So that conversation that you need to have with yourself and your architects around you is, how are you going to slot Druid in to your existing data pipeline? There's a whole other talk on that one, but it's sufficient to say at this point, if you're on the journey, think about this early. Now, as our friend gets more courageous, they'll find out that there isn't just one middle manager process that does all the ingestion. Instead, there are several of them. And that's part of the beauty of Druid. It's our ability to linearly scale its ingestion capability to many millions of rows per second. And that is not obvious in a single node deployment. At that point, our traveler will only see one task running. But as you go forward with Druid, you learn that the middle manager spawns multiple tasks that could be monitoring different Kafka partitions or dividing up whole buckets of files between different workers. And each of those needs its own resources and they share a different configuration. And then they'll also learn there's this thing called the router. It runs the console itself, and they will learn that it can act as an application gateway. So it provides JDBC connection stickiness, for example. That's really useful in larger deployments. Now, quite often, this component is completely passed by when you pick up Druid. So if you yourself don't know about it, go and look at it now. And if you've knowledge to share about how to use it, then let me know. I'd love to help you tell other people. So our clustered quick start is also the first time that our adventure knows explicitly about the metadata database and deep storage. In a single node deployment, it's all hidden away. Darby is used locally for a metadata database, and deep storage is on local disk of the node that they're running it on. So now our traveler has to ask themselves, what will I use? Will I use HDFS? Or will I use S3 for deep storage? And for my metadata database, will I use MySQL or will I use PostgreSQL? How resilient will those need to be? Importantly, which one of those can my team actually support well? And which of those do we know how to recover from disaster from easily? The eagle-eyed explorer will also see something else that many other people miss, and it's the location for all the ingestion logs in Druid. The logs tell people a great deal about what's happened at any given moment during an ingestion job. If you're on this journey right now, please don't forget this. You need to have a common location that you can use, not just now, but on into the future to diagnose and learn about the ingestion jobs that you run. It's a good idea to take a look at the logs yourself for your different types of ingestion task and to analyze them and work out what is used and when, and also to familiarize yourself with the kind of warnings and errors that appear in those logs. I whipped this up for you today. I hope you're all impressed. It's just a breakdown of the kind of information that you would see in the single phase subtask log file. That's the type of task that's used for batch ingestion, and it's full of information. And knowing the stages can really help you unpick why ingestion fails and how it performs. I know that there's a real drive in the community to try and make these logs better. So if you're interested in helping with that, then please let me know. Okay, so now Peter Marchall has done the clustered deployment quite a few times. So the last time I did it, I decided to set myself a challenge and I built this. This, my friends, is Druid running on a cluster of Raspberry Pis. So on the right-hand side, I've got 3 data servers. You can tell they're the data servers because they're the ones which have got the Ethernet cable in, the gigabit switch at the other end. And then I've got one which is my master server, one that's my query server. And then I've got one on the left-hand side, which I'll either turn into some kind of game kind of thing, or I might put Kafka on it. I might have to come and speak to you, Thomas, about Kafka. I know, I'm a bit mad. So one of my biggest issues was the very next component in our architecture, and quite a lot of people have never had to deal with it before. In single server quick start, you're presented with some standard configurations that you can spin up using kind of nano or mini, I think they are. But in a clustered quick start, and especially for mad deployments like I've built on Raspberry Pis, you need to not only set specific Druid functional configurations, but also spend time trawling through the Druid tuning guide to calculate all kinds of things related to this, Java. Oh, that's the wrong kind of Java. I, of course, mean this kind of Java, the Java runtime environment. And it can be super tricky to get it right. The heap sizes can be tricky to calculate. I've seen people who've tried to work backwards from the memory in a given node, people who've tried to work up from ingestion file sizes. It can be really tricky, a real pain. And if you don't know about it now and think about it now on your journey, then the out-of-memory will come and bite you. You'll start to see effort in the documentation to make this easier to work with. And if you've got tips and tricks to share, again, please let me know, because I'd love to have writing about how to optimize this better. I've even seen people create spreadsheets to try and turn the tuning guide into a calculation. And this sheet is something that I knocked up, but there are other people who've tried. I would love this to be a simple React app or something that just chucks out the configurations. That would be awesome. So we've got the JRE. We've also got those other dependencies and people being aware of how they make decisions about the different dependencies. The next level is this kind of thing. People who use something called flame graphs. If you're familiar with flame graphs, I am congratulating you. Flame graphs allow people to work out what specific work Java is doing on the nodes, and thereby to unpick the minutest of details as to how they can improve the performance of the cluster. There is an Imply article free to view. You're just going to have a look at that, and it runs through how to create a flame graph, how to interpret it. If you're the kind of person who reads that kind of thing, go and have a look. It's a laugh. But either way, the lesson to be learned here is that the JRE requires very careful consideration. I'm sure it does on lots of different platforms. And with Druid, it does require experimentation. So let's switch back to my Raspberry Pis. As you can tell, I'm very proud of this. You can see in the services screen that I have all of those Druid processes we've just been talking about listed on the screen. But what we don't see are those dependencies. We don't see Zookeeper. We don't see the deep store. We don't see the metadata database. And in some respects, that's a bit of a shame because the importance of those components to our traveler isn't made evident, especially Zookeeper, which in my cluster keeps all the components communicating well with one another, including distributing and balancing data and tracking ingestion jobs. So in a mission critical deployment of Druid, how can I tell if these components, all of these dependencies, are healthy and okay? How am I going to get alerts? In configuration, this is all I've needed to get my Raspberry Pi cluster to work. I've got my connection to my metadata database, to my Zookeeper, to S3 for my ingestion logs and for my segments. That's quite impressive because Druid is inherently loosely coupled. It was designed this way. You know, it's not SQL Server 2005 re-engineered for the cloud era. You know, I don't have to tell the overlord where the middle managers are. I don't have to tell the coordinator where the historicals are. It's very self-scaling. It's self-healing. That's awesome. But it's also quite scary because Druid is bringing together a lot of different platform components that work together. So in production, our Explorer may need to have some way of checking that all these things are healthy and that the communication pathways between them are working okay, and to use some kind of formal control mechanism to make sure changes to any part are well managed. Now, the basic thing that I can do is use something like this. This is just me calling one of the APIs in Druid from Postman, love Postman. So I get a really nice JSON view of the configuration that's being used right now by a particular process. So maybe our traveler would want to keep on looking at this information, not just to check that the service is up, but also to check that the configuration is the most current version. So in here, I can see my Druid storage configuration, I see my indexer logs, I can see my Zookeeper. Do I need to do something to make sure that they are correct? Do I need to do health checks on it? Yes, I'm using Postman for this, but maybe you need to do something more formal. Maybe you need to build some kind of monitoring into the system, something that will check that the configuration is propagated effectively to all the nodes, for example. If I've tempted you to go and build a Postman collection for Apache Druid, there is a cheat sheet. It's on the Imply website. It's built by one of my colleagues called John King. And of course, there's all the APIs on the Druid project site as well. And there's some really important ones for monitoring Druid in production. Please go and take a look and see what use you might put those APIs to monitor exactly what your Druid cluster is doing. And it would be bad of me to ignore this brilliant talk given by Super Awesome, based out of London, a fantastic company that protects the information about children in an advertising environment. And they talk about how this loose coupling that we've talked about has really helped them. They've been able to use Spot instances on AWS for their Druid cluster. And there's also a brilliant meetup talk they gave, which explains it in more detail. And being aware of the data available to them through the APIs is one of the ways they were able to build such an elastic infrastructure with high levels of availability, even though it's using Spot instances. Okay, so we've covered some stuff that you probably already know in the clustered quick start, and hopefully have made you think about some extra bits you might want to add on. We've got the Druid components and their dependencies, some of the ones that are kind of hidden from view when you start with Druid. And we also spoke a little bit about the importance of Java and of your configurations and of building observability into the cluster. So what about really big deployments? What have other users also used with Druid? Well, as I got my Raspberry Pis up and running, I realized that I was having to push lots of different configuration files around and keep them synchronized. Lots of JSON, a JSON tornado, if you like. And as I played with different Java and Druid configurations, as well as different ingestion specifications, I really needed to track what I was doing and to distribute them effectively. And our traveler on their journey will face exactly the same situation. So on our card, let's add somewhere where they can store and collaborate on and version control the runtime properties, the Java configuration files, the ingestion specifications, the different Druid tiering rules. And it's a place where we might want to build automation into that pipeline to actually deploy and apply those configurations. That sounds a lot like CI/CD. So it shouldn't surprise you about the kinds of tools you might use. Daria Litvinov, at the end of her Outbrain Virtual Druid Summit talk, talks about the use of Jenkins and Git for exactly this kind of thing. And there's also the Twitch talk from VDS2, again, where they're using Git and Jenkins. What about when people start to run into issues? Logs, my friends. Yes, more logs. It is all about the logs. Now, I've already mentioned ingestion logs, and that's apparent in the clustered quick start. We talk about that explicitly, but there are others. And on Druid Forum, you'll see that people are often asked to go and look at their logs. Not these kind of logs. We mean logs that are about the processes. And these are generated in log4j2, and in quick start, they end up in var sv. I meet a lot of people who either don't know they're there or just don't understand their importance. You can see in this snippet from my overlord and coordinator log that the coordinator was working out whether it needs to rebalance the data in the cluster. So will our explorer want to keep them in the local var folder on each node? Wouldn't want to do that. Or will they push them to a common network mount, maybe? Or will they aggregate them into S3? Questions come up about how to set the log4j configuration for rolling logs. And I've heard of setups where people aggregate the logs into a third-party solution for analysis. Maybe they push them into a search database like Elastic so they can explore them centrally as a team. So there's another component for you. Anything where you can store and analyze those process logs in the same way you would with any data platform, really. Next, a dive into my deep, dark past. This is what I used to use every day. I can still feel the metal of the units under my hand, and I've still got the scars to prove it when I cut myself on the top of it as well. This is what I know about. This is a day when I thought, what should I start Druid running on? I think of a good old compact Proliant ML370 with RAID 10. Excellent. But things have changed. When someone talks about disks that don't actually exist, I mean, what's that about? Never mind CPUs that don't actually exist. I know, I have to grow up. I've got to pretend that I'm 24, not 44. I now know that spinning up a container doesn't mean doing acrobatics and gymnastics with cardboard boxes. No, what people mean is the ability to create and manage places where Druid and all of its dependencies will run, each one with the right prerequisites installed and the right configuration deployed. In other words, for our travelers on this Druid journey, they need to select the right technology for them to spin up machines and platform services around Druid. Will they use GKS, for example, or will they do something homegrown? So, for example, Athena Health at Virtual Druid Summit 1 have given a talk on how they use Terraform to create this infrastructure. Splunk have developed the Druid operator on Kubernetes. Lots of great conversations about that in the channels at the moment. Great piece of technology. Do go and have a look at that video. And then another thing crops up. Another thing that doesn't really come to light until you start using Druid in earnest. And it's a weird one. It's the question of where the segments will actually be stored by the historical processes once they're loaded out of deep storage. Now in the docs, it says, put them on fast SSDs. If you're working in a containerized environment, though, how will you attach that to your pod? How will you attach it to the right kind of storage? What kind of EC2 machine, therefore, will you use if you're doing it on AWS? I can't tell you how many times I've met someone who didn't know that the size and the location of this segment cache was configurable. I even met one person, I hope there's not somebody on the meetup today, but I met one person who thought that Druid was limited to a sum total of 300 megabytes of data for analysis. They didn't know how to configure this. Now, as travelers on this journey, you may want to spend some time thinking about this. Some engineers have designed clusters where there is a 1-to-1 ratio between the segment cache size and the memory. Why do they do that? They do that to minimize the risk that there will be any kind of eviction from the memory mapped area on each node. Some people take a different approach. They decide on the local historical segment cache size based on the query patterns that will execute on those machines. So maybe they'll load more data. They'll have bigger caches on a set of Druid tiered servers. And on those servers, they'll have lower memory capacity and fewer cores because they have colder query patterns. Since Druid 0.15, we've had this beautiful data loader in the Druid console. You probably will all have seen this. It operates brilliantly. Here is where our Explorer will build up their ingestion specification and they'll submit it right from there. Now, I come from an era before the Druid console, so I am aware that behind this is an API. Whereas most new arrivals may think that they build everything through this user interface, they are missing a trick. Because I can use that API, and that's critical for any ingestion that needs to be done repeatedly, say a regular batch ingestion. And this console is not built for version control. So those APIs give us a way to attach a more mature tool for handling that kind of work. A very popular tool you will not be surprised to know for this workflow scheduling is a workflow scheduler called Airflow. So as well as the VDS talks from Outbrain and Target who talk about this, do go and take a look at the Avesta Technologies Druid Meetup video on this slide. And as a bonus, you get to hear from me for another half an hour. I give a talk on gotchas during Apache Druid POCs. And while it's a few years old now, there's a blog post by Simon Spatey. I believe he's from Rhodes Schwartz. He wrote this great article on using Druid with Airflow and Superset at the back end. Now, in Quick Start, you also don't touch on an extremely important part of operating Druid well, and that is the metrics. We're talking about somewhere where we can collect the observability metrics out of Druid and analyze them. All of the Druid processes emit some kind of useful information. So the question is, how will you surface that? Will you push it into Grafana and then visualize it? Maybe you'll even push it back into Kafka and then on into another Druid cluster and put Superset on the top. Information about these metrics is in the documentation. There are metrics for the real-time ingestion jobs, for general health information, including the JVM, and also for monitoring query performance. There are emitters for Graphite, for InfluxDB, for Kafka, for Ambari, StatsD, whatever you choose, these are really important. They give you the kind of information that makes the difference between an okay Druid cluster and one that is highly optimized, one that is constantly improving, constantly being tuned by people like you to make it more cost-effective and performant. A few months ago, Abhishek Dubey published this article on how to use Prometheus to monitor Druid. And as before, if you have your own metrics monitoring going on for Druid, please get writing and let me know. People who are just picking up Druid need to know about the importance of metrics and how they go about collecting and analyzing them. Now, maybe you're feeling a little bit anxious one day and you'll go a step further when it comes to query performance. Maybe you'll use JMeter. Now, JMeter is fantastic. We've used it for benchmarking Druid. I've seen other people use it for benchmarking Druid. And we use it to set up and monitor standard queries and to improve their performance over time. Also, don't forget that in Druid, you can set a query ID in the query parameter. Why is that useful? That's really useful because I can look at the metrics in Druid and see how query performance is trending over time and then do something about it if it gets significantly worse. You see, metrics are essential not just for the daily operation of Druid, but also for building a complete data pipeline that delivers on those dreams, sometimes nightmares, of product owners. Just one example of that is back in that super awesome post, and they've explained how the ingestion lag metric that Druid emits doesn't just help them monitor the health of Druid streaming ingestion, but it also indicates that they may have an issue further upstream, say with the actual producers of that data. Maybe that website's gone offline. Now, speaking of dreams, how will people actually look at the data? What's the target application? Is our traveler going to use the JDBC connector and query in SQL? Will they submit queries to the API directly in native Druid JSON? Or will they plug in a React or a Xamarin or an Angular app on the top? Will they connect a data science notebook like Jupyter and Zeppelin? Or will they write in Python and R directly? Or will they plug in a BI tool like Superset or Tableau or Looker, or come to Imply and use Imply Pivot? The question about how this application is going to be built, what it's going to do, and the queries it's going to execute, the end user audience, are really important for everything I've talked about previously, about knowing what metrics to collect, about what types of queries, and understanding how and when you should scale the Druid cluster for an increase in the number of users, for example. So here's some good examples of places to go and look for people who talk about this kind of thing. We have the Target talk, the retailer in the US. They gave a virtual Druid Summit talk, I think back in, I'm trying to think now, probably May, something like that. It's all a blur. Go and have a look at this. Jeremy Wolfel is fantastic. There's also this example of an interface built by Game Analytics, a company that I know very well from here in the UK. They spoke about their own front end, building a real-time gaming analytics service. Fantastic user interface, but also very clear about how they've scoped and sized their Druid cluster. And there's also InnoWatts. InnoWatts are analyzing electric meter usage using Druid. Maybe our end users will do something really cool and they'll plug in Facebook Profit. And they might do that in the same way that Preset have shown in a recent blog post. You can have a look at that, our colleagues in Preset. You see, it's very easy for us and our travelers to think, I know, I hate MongoDB, I'm going to put Druid in instead. But that's kind of missing the point. I learned that lesson after the recent VDS4, and I wrote this post in the Druid forum, and it's there to kind of summarize the key qualities of applications that are built on Druid. And it might inspire you, it might inspire our traveler and the people on the journey with you to think differently about the user experiences you can deliver in Druid, and not to just swap out existing solutions because Druid is the very latest super fast time series data warehouse search engine, but to dream and to think big. Right, time to wrap up. A couple of bonuses for you to think about. First of all, I have seen people take the default query cache engine and to plug it into a dedicated caching service. This is in AWS. There are some deployments where people have done that. It's kind of unusual, but it is possible. If you want to do something different with the caching in Druid, you can do that. And secondly, or as an important one really, Druid does use a lot of HTTP inter-process communication, so you will need to think about securing it. You may need to think about how you're going to provision and deploy certificates. You might want a web application proxy at the front end. You might want a network load balancer. You know, you might have to actually conjure the courage to go into the basement in the dark and speak to your network engineers. Oh, the thought of it. Anyway, so new just for you, I've also posted this in the Druid forum recently, lots of other observations on things you need to think about when you're going into production with Druid. Okay, all done. Thank you very much. So we've built our list of components. We've looked at the quick start. We've looked at the single node and cluster quick start. And I've also given you some information about what's out there in the community. Of course, these slides will be shared with you, so you'll be able to go and look at those videos and those blog posts I've put on there. So let's look at our completed card. At the top left-hand corner, we have all the Druid processes. Zookeeper smack in the middle. We have our data stores in yellow at the bottom, including some that you would need to use for observability. We have the JRE. We have at the top right-hand corner our target application, tooling around software and hardware configuration, our workflow scheduler, and then those bonuses at the bottom of the query cache and HTTP. My personal priorities from this card, if I was going to recommend what you'd look at, definitely take a look at Airflow, look at how you're going to manage your infrastructure, and especially the JRE, look at how you're going to analyze metrics, and think about the tool you're going to use to control and distribute those configuration files, those ingestion files. Reminder, you're not on this on your own. Every single one of the people I've mentioned today, we're all active in the community, whether it's Seidel Bashir at Super Awesome or Kevin Peng at Amaby or individual contributors like me. If you've got any questions like this at all, come and speak to us, come and say hi. And I hope this was useful for you. So I shall stop now and take questions while I set up the demo.
Yep, we are still waiting on questions, so don't be so shy. And if you have any question, raise a hand or write a chat, or I will unmute you. So
yeah, and do keep asking questions, you know, as I go. Okay.
Oh, no questions. So
oh, that could be bad.
Or it's good one because your presentation is so good that explain everything. So depends on how you look on it.
Thank you. Yeah, so I'll definitely share the slides, and also got a post and some other stuff to follow this as well. So
oh, wait a second, there is a 2. Oh, even more. So
the previous one as well. Oh,
I will start from Sugar, okay? It's very good one. Good presentation. And the question, will we get the slides? A lot of references were given. Yeah, we think we can post the link on meetup.com site, right?
Yeah, cool. And I'll also separate out all of those. I'll make a note for myself to separate those all out and make sure that I've got a post somewhere that has them all listed as well, make it easy to access.
Okay, another question from Sumit Rao. Also, can I get a link to the previous presentation? Yeah, there is a recording on our YouTube channel, so I can drop it. And Philip, the good presentation from any comment you asked for.
You're all too kind.
Uh-huh.
Okay, so 5 minutes. Thomas, is that all right?
Yep, that's good.
Okay, cool. So are you all ready? I'm expecting the blue screen of death. Oh, that sounds, now I'm showing my age, the blue screen of death. When was the last time I saw that? Okay, so here we go. Quick. This is a Windows machine. It's got an Intel Core 2 Duo processor in it, believe it or not. It's gathering dust. So what I did was I've got Oracle VirtualBox running here with Ubuntu in it, and this is where I'm running MinIO. So MinIO is providing me the S3-like service for the ingestion logs and for the segments. And you can also see I've got MySQL running here. This is really useful to go and look at, actually, because I can see the underlying metadata database. I can do queries on the segments. I can do queries on the tasks that are running. It's quite a useful thing to be able to see. And it also validates that things are actually connected correctly. So that's, I've got a Windows machine where I've got MySQL and I've got MinIO running for my S3 service. And as this is the decision that I took about where my deep store should be, and it's purely because I wanted to play with MinIO. But you know, you need to think about, as I said, the level of availability, the performance, and how familiar you guys are in your organizations with that particular technology. So I'm using, this is the MinIO browser. This is quite cool to be able to look at. the individual logs. Now, because I've got this indexing log thing set up, I get all of the logs for everything I've ever run. And that's really useful just to be able to go and look at and see what's there. Of course, I can also go and grep this stuff in the location on the machine should I want to. I'm also using this as a source to load data from. So I've got, I'm playing around, the part of this experimentation, I'm playing around with different splits of the Chicago taxi data set to find out that sweet spot for my ingestion tasks. I think these are actually a bit small. I could probably make them a bit better. So I'm just personally learning more about the ingestion by playing around with how many files there are in this bucket, how big they are, and so on. So let's have a look at the dependencies just to show you. This is quite cool. So I'm using the Zookeeper shell client, and I can do something very radical. So I can see all of the different I'd say endpoints in Zookeeper. I can see all of the different machines that are announcing themselves. I can see the segments that they're advertising. I mean, this isn't the kind of level you'd usually go to. This is because we like this kind of stuff. But it is interesting to watch what Druid is actually doing inside Zookeeper. Now, my Zookeeper is running on my master node. That isn't necessarily a good idea, because if I need to restart my master node, let's say I want to do a rolling upgrade or something like that, then I'm going to lose Zookeeper, which is daft. So what I need to do in this situation is to move Zookeeper off my master node and put it somewhere else. I mean, I could put that onto that spare Raspberry Pi, actually. It doesn't require a lot of resources. And so then I can do rolling upgrades on my master nodes. I could spin up more than one master node than I currently have. Okay, I also on here have, this is where my processes are running. And at the moment, all of those process logs that I talked about are all being emitted into var sv on this folder. So I have a job for me to do to make sure that I'm pointing those process logs somewhere else. So you can see the number of machines are here. I've got the master server, 3 data servers, and a query server. How have I configured all of this? How have I distributed the thing? Because all I'm doing is just using the, as you can see, I'm just using the general start command that comes when you just download Druid. Well, what I have on my Mac is I have, this is Sublime Text. I have a folder called apps, and in there I've downloaded the various distributions of Druid. 21 will be coming out soon, and I can't wait. I'm hoping it's just a few days away. We shall see. So I'm running 20.1 here, and that's 20.0. And I'm using a very simple shell script to rsync to each of my Raspberry Pis. It's doing something very simple. It's not very complicated. As you can see, it's just taking that folder and then sending it to the home folders on each of those Raspberry Pis. You wouldn't do that in production, right? But it is a way to do it, because, for example, when I've deployed a particular configuration, I need to restart the services. Well, this script doesn't bother to check the service has gone down gracefully or come back okay. My only way of doing this properly is to go into the node, stop the processes manually, and start them again. You can see how that kind of software and infrastructure control bit that I was talking about, I'm missing that here, and that's really going to cause me pains. So I also then have my common runtime properties file. This is just in the common folder. I've got my configurations in here for the MySQL metadata storage extension. I've got my connection to Zookeeper. I have my metadata storage, the configuration for the S3 extension. I've got my segment store, my log store, and that's about all that's really interesting in here, other than my fantastically encrypted password, which I'm very impressed with. I mean, it's over 10 characters, right? It must be great. So I've got my common runtime properties shared by all those processes. I then have the runtime properties. And in the runtime properties, obviously, I'm setting all the functional configuration. But the JVM config is the thing I was mentioning a moment ago, that JRE. How do I know the size of these XMS and XMX settings and that direct memory size? That is where you've got to go into the tuning guide. Or if you're lucky, just lift one of the standard configurations for say an i3 4x large. But there's one that's often missed, and that is in the runtime properties for the middle manager. I also have this Java setting here. And this is for each of those middle manager tasks that get spawned. And it spawns that many. So there is that element of the JRE as well as the JVM configuration files. In the router config, just to prove this thing is live, I have my actual router port number, and that is where my postman is connected to. So I can run a very simple query like this one. This is just telling me the status of that node. In this case, it's going to my master node. I also have this one, which is a bit daft, but it exists. It just says true if the service is alive. And I also have that properties API I was showing you earlier with all of the configuration properties. It sounds like it wouldn't be that valuable, but it really is. When people are doing rolling upgrades and they're trying to work out how they should change to a new version of Druid, for example, often people will deploy the configuration and forget to restart the machine. And it's just using this API, you can work out whether someone's running the right version and whether the configuration is propagated. I also have some other useful ones. I have one here that tells me how loaded a particular data set is on the cluster. So I can see here that the taxi data year 8 data set is 100% loaded. And I also have a full list of all the data sets. If I only just needed to re-emphasize that with this data set, I've had to re-index and experiment, put my data engineer's hat on and work out the best way to structure the schema, to structure the segments, that ingestion specification, so that the performance of my queries is magic, is its best as it possibly can be. I'm not plugging in Wikipedia, Airflow here, which is a shame because I would like to be able to plug Airflow in. You know, I would love to be able to play around with that a bit. And it has got me into issues because as I'm playing around with different ingestion specification settings, for example, I'm not able to just pick one up and, oh, I just want to tune that bit. I'm having to copy and paste between Google Docs and all sorts of things. So you can see my data sources here. You can see the services are live. This is real, folks. My number of slots, that's all useful. As I said, it doesn't give you full visibility of the cluster. And I can also run my queries in here. I would love to be able to get superset on the top of this. The other thing that's missing, to hammer this home, is metrics. So this query is taking a while to run. I have no idea why. If I was plugging in the metrics emitter and had some kind of way of looking at those metrics, I might be able to decode exactly why the performance of this query is a bit rubbish. I've got a suspicion, but I'm not sure. And it's always great to have evidence. So I would love, as my next step on this, to be able to emit metrics into Kafka, Kafka into Druid, and then superset on the top of it. I'd be very happy about that. Okay. So there you go. This is my Raspberry Pi Druid cluster. It is possible. Everything works. The queries are highly performant sometimes. But it's a really great way of learning how to use Druid. Exactly the same journey. So there you go. Bit of an intro to Druid running on a Raspberry Pi cluster. Any questions?
Okay, is it really the Raspberry Pi?
Yeah.
Oh.
I have, so the data nodes, which are data 1, 0, and 2 here, they are 4 gig quad core. So like the one that's like $70, I think. I did have it running on the 4 gigabyte quad cores, but my issue was the JRE, because I was not able to have enough workers running. I could really only afford to have one worker running. So when I was ingesting 73 terabytes of Chicago taxi day set data, it was just taking too long, essentially. So I convinced my manager to allow me to purchase bigger ones. So yeah, and then the broker and the router, they're running on the same machine. That's just a Raspberry Pi with 4 gigabytes of RAM, and the master again is another one with 4 gigabytes of RAM. It's actually a little bit over-spec'd for those because they don't require a huge amount of memory. So the router and the broker don't require a huge amount of memory. But yeah, I've got a blog post about this coming out and the trials and tribulations of using very small machines. So I'll send you that one.
So you are a competitor of the AWS or GPT?
Oh yes, absolutely. I would love, like, if I had all the money in the world, I would love to be able to buy another 6 and just, add a whole load of data servers. You could just go on and on. I mean, essentially, it was just a way of me having to avoiding learning Kubernetes and buying a load of AWS time. Instead, I just went and spent, £200, I think, or something, and bought a whole load of Raspberry Pis. It's just been brilliant to learn about Druid and learn slowly, because Druid can be very fast, to watch the logs as things happen and see that when ingestion is processing, what is it doing as it's processing the files? Which files is it processing? And to do that live as opposed to doing it after the fact. It's just really useful. And I can break it and throw it off the desk and no one cares. And my boss doesn't keep telling me to turn AWS instances off all the time. It's just running all the time.